The change in Gibbs free energy is defined as the change in enthalpy minus the temperature times the change in entropy at constant pressure and temperature. We know that because delta G is also equal to negative T times the change in entropy of the universe, that any time the Gibbs free energy decreases, so if delta G is less than 0, this corresponds to an increase in the entropy of the universe. So if delta G is less than 0, then a reaction or process will be spontaneous by the second law of thermodynamics. So if we come back to our definition here, we want to look at how the enthalpy and entropy of the system affect the sign of the change in Gibbs free energy. Well, for something to be spontaneous, we want delta G to be negative. So delta H is negative when a process is exothermic. So we want delta H to be less than 0, so exothermic will contribute towards a negative delta G, so this is favorable. Because there's a negative sign here, a positive entropy change in the system will contribute towards a negative delta G. So when delta S is greater than 0, this is favorable as far as contributing towards a spontaneous reaction. So if delta H is negative and delta S is positive, then delta G will be negative. If we had delta H negative, so this is case 1, here's case 2, if delta H was negative, so we had an exothermic reaction, but delta S was negative, then this term here, because it would be negative times a negative delta S, would be positive, so that would contribute to increasing delta G. That would be not favorable. So this process will only be spontaneous if this temperature term is small, so that it minimizes the effect of the entropy term. So this will be spontaneous always, the first case, at all temperatures. This one, we don't know what the sign of delta G will be. It will depend on the temperature, and it will be spontaneous only at low temperatures. If we had, in case 3, an endothermic reaction, but with a favorable increase in entropy of the system, delta H would be bigger than 0, but this term here together would be less than 0. So if temperature was big, then the entropy term would dominate and overall delta G would be negative. So we don't know what delta G is, it depends on the temperature, but overall the reaction would be spontaneous, that is delta G would be less than 0 at high temperature. Now the final case would be if the enthalpy change was positive, so we had an endothermic process that involved a decrease in the entropy of the system. In this case, this term is positive, and this term would have a negative and a negative, so overall it would be positive. So no matter what we do, delta G is going to be positive. So this process would be not spontaneous at any temperature. Let's look at how we could apply this. Consider if we had a reaction such as calcium oxide as a solid reacting with carbon monoxide as a gas and going to calcium carbonate as a solid. Now we can see here that because we're going from 2 molecules, 1, 2, to 1, and because we're going from a solid and a gas to just a solid, that this has an entropy of the system change that is less than 0. It involves a decrease in entropy. So we are either in this case here or this case here. If I were to tell you that this reaction was spontaneous, you would have to conclude that delta H was negative, that it was exothermic, because otherwise delta G would always be positive and you wouldn't have a spontaneous process. So you could conclude that this reaction is only spontaneous if delta H is less than 0.